do have a little typo. I forgot to tell y'all that. Shoot, shoot, shoot. That 2 is a typo on my part. I apologize. I don't think it's going to mess y'all up, but it's supposed to be a 1. Okay, so I told you that it was a weak base, right? So it's going to do something a little different. I just want to see, did you get this far? Notice I had to take that 2 away because that was a typo I forgot to tell y'all about in the beginning. Probably because my Promethean wasn't acting right with me today and didn't save my stuff yesterday, even though I asked it to. All right, does your ice chart look something like this? Uh-huh. You are. It's that 2. I had an extra hydrogen attached to at the end. It should just be NH. Your base should just be the NH. It's dimethylamine. I just had an extra hydrogen on it. Does your ice chart look like that? Okay. So at equilibrium, did you write down this at equilibrium? Did you write that down at equilibrium? Okay. Did you write the KB expression? Because we need a little practice with doing that appropriately and properly. You might have a 3 on yours just because I messed you up. Don't worry about that part today. OH minus. C2, H5, and H1. All right, does your KB expression look something like that? KB. It's the KB. Now and I'm glad we're talking about that. Why is it a KB and not a Ka? Because it's a base. They gave you the Ka of his conjugates. And what I have to keep in mind is since he's a base, I have to have the KB. Okay, and the only reason you might know that, because you're probably not that familiar with your amines yet, is I told you he was a weak base. Okay. He's a weak base, so you need the KB. All right, so I can't use my Ka directly, but what I can do is I can come up here and I can remind myself that Ka times Kb is Kw, yes? And so I can say, all right, then 1.923 times 10 to the minus 11 times my Kb value will be, and what's Kw again? Have to have that memorized. 1 times 10 to the negative 14, because you're going to need to know that. You can't spend your time hunting for constants like that you really need to know their values. All right, so when I go and I do my math, and I find the Kb value, I have a negative 14, I have a negative 11, I end up with a value that's about a negative 4 for my Kb. So the Kb is something times 10 to the negative 4, and that's going to end up being x squared over 0.5. And I think it's 5.2 times 10 to the negative. When I go up there to do my Kb, I end up getting a value of 5.2 times 10 to the minus 4. And when I put that in my Kb expression, I'm going to put x on top and x on top and 0.5 on the bottom. So when I go to do my expression and then I go to do my plug and chug, this is what my plug and chug is going to look like. Agreed with that statement? Okay. Go up a little bit, not quite that much. Just disappeared on me big time. All right. So we'll leave it like that. Now, when I go to do my math, I'm going to get something equaling x, and x, according to my ice chart, is not hydronium, it's hydroxide, yes? Okay. So I'm going to have 2.6 times 10 to the minus 4 square root of him. So square root of 2.6 times 10 to the minus 4. Here, square root in that needs to help. 2.4, 2.6 times 10 to the minus 4 is 1.61 times 10 to the minus 2. 1.61 times 10 to the minus 2 when I go to do my math and similarity value. That's my hydroxide. When I go to do my math right here, that number times a half becomes 2.6 times 10 to the minus 4. When I square root it, I square root both sides, I end up getting 1.61 times 10 to the minus 2. That equals my x. That equals my x. Yes? Absolutely. Absolutely. All right, Mike, are you with me? Okay. All right, now, question. How do I get the pH? Okay, what do I do first? All right, since I have the OH, if I take the minus log of x here, minus log of x, that's not going to give me pH, is it? That's going to give me POH. Agreed? Now, here's an example of if you're not paying attention, you're going to try to use my Ka instead of the Kb that you need. And if you're not paying attention, you're going to minus log x and say that's the pH. And I'm going to say a weak base has a pH of 2. What? You got to be careful with your acid base. Did I say this unit was hard? It's hard because there's so many little details that if you haven't laid your foundation yet with your acids and your bases and your salts and your math stuff of how do I get a pH and how do I get a POH and how are they related and how are H plus and OH minus related, how are Ka and Kb related, how do I write a dissociation equation? All of that is laying the foundation. That when I get you into chapter 15 next week, if you have not allowed yourself to lay the foundation for chapter 14 here, you are in the deep end and you're all the way at the bottom and you're not coming up. Chapter 15 cannot be accomplished unless you help yourself get on board in this chapter 14. So that's why I did the little curveball on this one. I gave you the Ka when you needed the Kb. Because I need you practicing those curveballs they're going to throw at you and be ready for them. It takes practice. It takes time. We've got to keep doing them. All right, so who got a POH for me? 1 point what? 1.037 for the POH. .79 and something else to give me that 3 sig figs, 3 decimal places. 793. All right, and so what is my pH? 14 minus 1.793, so 12.207. 12.207. Why does that look better for a pH of a base? Because it's above 7, because it's a base. If it's a base, it better be above 7 for the pH, not below 7. You got to pay attention to those kind of little details. Yes, you do. Yes, you do. All right. So why did I extend the owl